Boys and girls, this is Mr. Manise here again with another very cool video, and in this video I'm going to walk you guys through how to solve every problem on the Unit 2 test review. We were talking about angles and lines, perpendicular, parallel lines, different types of angles. My disclaimer as always is I need you guys to work out every single problem on your own and figure out what you know, what you don't know, where you're stuck, where you might need some extra clarification, and then and only then come to the video and fill in the gaps. So there are 73 million problems on this review. Actually, I think there are only 73. Sweet Lord of mercy, Mr. Money, 73 problems. Yep, 73. However, a lot of these will go very, very quickly because a lot of these we're just naming the different types of angles. Obviously, the test won't be near this long. So without further ado, let's go ahead and jump in. You've got everything here listed that you need to make sure you are fully prepared for the test. And guys, remember, just because it's not on this test review does not mean that it won't be on the test. Okay, so you're always susceptible to seeing some problems on the test or the quiz that are not on the review. Okay, remember this is the honors class. Okay, so got to keep that in mind. All right, so let's go ahead and jump on in here. So first one here is asking for ask us to determine whether each statement is true or false based on the diagram at the right, and then explain our answers. And it's saying that angle 1 and angle 5 are adjacent angles. What do adjacent angles mean? That means that they share a vertex and they share a ray in the middle. So they're basically touching each other, they're side by side. Yes, angle 1 and angle 5, they both share this vertex right there in the middle. They are sharing this ray. So yes, that is true. That is a true statement. And why is that? Because they share a common ray and they share a common vertex. Okay, common vertex and ray. Number 2, 3 and 5 are vertical angles. Okay, now remember, for vertical angles, basically vertical angles are formed from an X, right? Two intersecting lines. So angles 1 and 3 would be vertical angles. Angles 2 and 4, those would be vertical angles. Angles 5 and 3 are not vertical angles, okay, because we don't have the X, right? We have to have opposite rays here. Okay, so angle 1 and angle 3 would have to have opposite rays. But this is an obtuse angle, this is an acute angle, so obviously vertical angles are congruent, so in this case, no. False, okay? Number 3, 3 and 4 are complementary. Complementary means they add up to 90 degrees. Angles 3 and 4 form a straight line, so obviously that is false. Number 4 says 1 and 2 are supplementary. Okay, supplementary means they add up to 180 degrees. So that's false. So basically they got these guys backwards. Okay, 1 and 2 would be complementary because they add up to 90. There's my 90-degree box. And 3 and 4 would be supplementary because they form a straight line. So they got these guys backwards. Both of those are false. Okay, let's keep going here. All right. Next up, we say we've got this diagram over here to the right. It says name an angle or angles in the diagram described by each of the following. Okay, so we're trying to find an angle that's supplementary to angle AOD. Okay, so where is angle AOD? So AOD, that means this angle right here, this big obtuse angle. We need something that's supplementary to that, meaning it forms a straight line. So there's actually a couple of different answers to this. If we look at this straight line, okay, we could say that AOB, okay, also forms a line with angle AOD. Okay, so angle AOB works. Or we could look at this line right here, okay, and we say AOD plus DOC, okay, that angle and that whole angle, they would form a straight line. So I could say or angle DOC or COD, however you want to write it. Number 6, adjacent and congruent to AOE. AOE. Okay, so that's this 90-degree right angle. I need something that's adjacent and congruent to that. So the only other angle on this diagram that is also 90 degrees would be this guy right here that forms a box on the other side. So that would be angle EOC. Okay, that would be adjacent and that's also congruent. That's also a 90-degree angle. So angle EOC. We do not have an EOC in this class. Number 7, give me something that's supplementary to EOA. EOA, okay. EOA is a 90-degree angle. So if we're supplementary to that, then it's got to add up to 180. Well, 180 minus 90 is another 90. So basically this is asking, give me another angle that's also 90 degrees. Okay, well that's basically what we just did in number 6. Okay, we're going to get the same answer. Okay, EOC, this angle here, would be supplementary to EOA because they're both 90. They both add up to 180 degrees. So we're going to get the exact same answer. Angle EOC is both congruent and supplementary to angle EOA. All right, give me something that's complementary to EOD. 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 Something that is complementary to it means it adds up to 90. So this guy is 60 degrees, so I need another 30-degree angle that adds up to 90 degrees. That would be this angle here, because we already said that forms a box. So angle DOC would be supplementary to form a 90-degree angle there. A pair of vertical angles. Again, so vertical angles, I'm looking for an X. The only X that we have on this diagram are these two lines right here. Okay, give me a pair of vertical angles. So this angle and this angle would be vertical angles. They're on opposite sides of the X, angles 1 and 2. So I can say angle AOB and angle DOC would be in the little crevice of the X. Angle AOB and angle DOC. Okay, there's my vertical angles, and those guys will always be congruent. Number 10, EFG and GFH are a linear pair. Linear. They form a line, okay? Here are the two expressions for those two angles. What are the measures of each of those two angles? Okay, so I always like to draw myself a little picture here. So something like that, a linear pair, they form a line. So let's go H, F, G, and E. So it says EFG, that guy is 2n plus 21. Okay, and GFH is 4n plus 15. Always draw a picture in geometry, guys, especially when you're stuck. You're not sure how to get started or where to go. Okay, so it's asking us for the measure of these two angles. Okay, so if they form a line, they're a linear pair. That's a big angle, that's a little angle, one big and one little. They're going to add up to 180. They're supplementary. So I'm going to add those two guys together, 4n plus 15 plus the second expression. All of that's going to add up to 180 degrees. That's going to be 6n, that's 36, equals 180. Subtract 36 from both sides. 6n is equal to 144. Divided by 6, and we get n is equal to 24. Okay, so n is 24. That's not what your boss asked for. Your boss asked for what? The measure of these two angles. So I got to take this guy, plug him in right there, and plug him in right there. So this angle, if I plug in 24, I've got 4 times 24 plus 15. That is going to give me 111 degrees. Okay, so this guy is 111 degrees. And then EFG, okay, if I plug it in here, I've got 2 times my n, 2 times 24 plus 21. That comes out to be 69 degrees. So this guy is 69 degrees, and we can double check our work, and we can say 111 degrees plus 69 degrees. Yes, that does add up to 180 degrees. So that works. Okay, moving on to the next one. Algebra. So we've got an angle bisector. GH bisects FGI. Okay, so if it bisects it, these two angles are identical, and they're showing us that with the two little arcs, and they're also telling us that it bisects the angle. So we've got an angle bisector. And it says solve for x and find the measure of angle FGH. Okay. All right, so the measure of FGH. Okay, so we know that both of these angles are the same, so I can simply set these two expressions equal to each other. So I can say that 3x minus 3 equals 4x minus 14. Okay, let's go ahead and subtract 3x from both sides so I can keep a positive variable. I'm going to add 14 to both sides. X is equal to positive 11. Okay, so we solved for x, so we got that. Find the measure of angle FGH. FGH. So if I plug this guy right in here, I've got 3 times x, 3 times 11 minus 3, that's 33 minus 3, that equals 30 degrees. That means this guy is 30 degrees, okay? And then it says find the measure of HGI. HGI. Well, yeah, you can go ahead and plug this back in here, but it's an angle bisector, right? So we know that these two guys have to be congruent. Let's plug it in anyway. I have 4 times 11 minus 14. Oops, sorry. 4 times 11 minus 14. That's 44 minus 14. And a D, that does give us 30 degrees. So that guy's 30 degrees. Okay. So FGH, HGI, and then it asks us to find FGI. Okay, so if that guy is 30 and that guy is 30, then the measure of angle FGI is you add those two together, and that will be 60 degrees. Okay, all right, let's keep going here. Moving right along. Okay, now we're just going to name some angles. This is our classic two lines that are parallel. Or actually in this case they're not parallel, they're just asking us to name these names. When they are parallel, then we have a lot of theorems, alternate interior angles are congruent, that kind of stuff. But these are just two random lines cut by a transversal, and let's name our angle pairs 3 and 6. Okay, 3 and 6. Alright, so they are both on the same side of the railroad tracks. Okay, again, I like to think about these as like a railroad track that's intersecting two car roads. They're both on the same side of the, if you need to turn your paper, they're both on the same side of the railroad track. They're both on the right. Okay, so on the same side. And here are the buns of my hamburger, right? Here are the two roads. If you want to think about a sandwich. Okay, they're both inside my sandwich, right? They're inside the hamburger. So these guys are going to be same side interior. Okay, 1 and 2. 1 and 2 are right here. Okay, they form a straight line. Okay, line, so they are a linear pair. They're also adjacent, but the more technical, the more accurate term is they form a linear pair, because a linear pair means that a linear pair means they add up to 180. Adjacent angles don't have to add up to anything. All right, 1 and 7. So you got 1 on the outside of the sandwich, 7 is on the outside of the sandwich, so they're exterior. And they're on the opposite side of the railroad tracks, right? 1, if you turn your paper, 1 is on the left, 7 is on the right. So they're opposite sides, so they're going to be alternate. And they're outside the hamburger, outside the rows, so they're alternate exterior. 3 and 5, okay? 3 is inside the hamburger, 5 is inside the hamburger. Okay, 3 and 5, remember the Z? Remember I taught you the Z? Here's the Z. It's a backward Z, but it's still a Z. So if the two angles are in the little crevice of the Z, they are alternate interior angles. Alternate interior, okay? And then we got angles 4 and 8. Okay, 4 is inside the sandwich, but 8 is outside the sandwich. So the only angle pair that we know of that has a name where 1 is inside and 1 is outside is corresponding. Now doesn't necessarily mean they're always corresponding. We have to check. And the little trick that I taught you guys was draw your little box, draw your little window. Corresponding angles are in the same position in the window. In this case, 4 is in the bottom of the window, 8 is in the bottom of the window. Okay, or if you kind of turned your paper this way, 4 is in the bottom left and 8 is in the bottom left, however you want to look at it. So they're in the same corresponding position, so those are corresponding angles. Okay, all right, moving right along. Okay, the next one, got some little real-world application here. We got an airport with some runways there, and it says the photo shows an overhead view of airport runways. Are angle 1 and 2, are they alternate interior, same side interior, corresponding, or alternate exterior? And that's kind of hard to see in this diagram. But here are our parallel lines and the transversal. Here's angle 1, and there's angle 2. Okay, so once again, if I draw my little box, sorry, it's kind of hard to see here. If you draw your little box, 1 is in the upper left-hand corner, 2 is in the upper left-hand corner of the window. So these are going to be corresponding angles. Apologize, that's so hard to see. Okay, number 18 says for 18 through 20, find the measures of angles 1 and 2. All right. So these lines are parallel, so we're seeing that with the arrows here, the double arrows, arrows. So always got to be looking for these arrows. Okay, so if the lines are parallel, then we can use a little trick that I taught you. One big and one big are congruent. If they're both little, they're congruent. If I have one acute, one obtuse, one big and one little, they add up to 180. So 75, that's obviously little because that's less than 90. Angle 1, is that obtuse or acute? That's less than 90. So those are both little. So I can say that angle 1, measure of angle 1 is also equal to 75. If we want to use our theorems and our angle names, our pairs, we can say that 1 is in the bottom left of the window, 75 is in the bottom left of the window. If I were to draw my box, 1 is in the bottom left, 75 is in the bottom left. So those are corresponding angles. Okay, now how do I find the measure of angle 2? You can do this a couple of different ways. Easiest thing for me to do is just look at these two angles here, angle 2 and angle 75. They form a straight line. Okay, so they're a linear pair. So they're supplementary. They got to add up to 180. So I'll just do the measure of angle 2 is 180 and subtract this acute angle, and that's going to leave me with 105 degrees. Okay, number 19. We've got lines A and B that are parallel. And here's basically the same thing that we were just looking at. 120 is an obtuse angle, 1 is an obtuse angle, or if you draw your window, 20 is in the bottom right. If I draw my window, 1 is in the bottom right. So 1 and angle 20 are both corresponding. So the measure of angle 1 is also 120 degrees. Corresponding, I'll just abbreviate there. How do I find angle 2? Same exact thing that we just did here. 1 and 2 form a straight line, so they're a linear pair. They're supplementary, add up to 180. So I'll do the measure of angle 2 is equal to 180 minus 120, and that's going to give us 60 degrees. Number 20 is a little bit tricky. Now, anytime I see a problem like this, guys, we got a triangle, kind of quadrilateral, something like that, I'm always looking to see what can I add to my drawing that's going to make it easier for me visually. And so I see these arrows here, so these lines are parallel. So what I like to do on something like this is I like to, we're used to seeing this kind of thing, right? We're used to seeing two lines cut by a transversal. Well, we don't really see that image here, so let's make that image. I'm going to go ahead and extend the bottom side there. I'm going to extend the top side here just so I know we've got parallel lines. And then I'm going to extend these transversals. Let's extend that one and let's extend that one. Now notice that, again, I tell you guys, take your eyeballs and throw them in the trash can. It doesn't matter what it looks like. But you can clearly see here that it doesn't appear that these two lines are parallel, and we don't have any arrows. It doesn't matter what our eyeballs think. Well, we don't have any arrows. So AD and BC, we don't know that those are parallel, but we do know that AB and DC are parallel. So really, guys, what you need to do is, since we don't know that these two lines are parallel, what you need to do is act like this other line is not there. Okay, it's almost like you got to treat this as two separate problems. Now we're looking, we've got our two lines cut by a transversal. Okay, so what do we know about this angle and that angle? Okay, we already know that A, B, and DC are parallel. Okay, so here's the Z, right? It's the backwards Z. Always look for that Z, and we're in the crevice of the Z. We're on opposite sides of the railroad tracks. We are inside the hamburger bun. So these are going to be alternate interior angles, okay, and those are going to be congruent. So the measure of angle 2 is also 70 degrees, okay. Now if I look over here, now it's almost like we got a separate problem. Okay, these two transversals have nothing to do with each other, okay. If I have this transversal and another transversal over here, then none of these angles over here, none of these angles have anything to do with any of these angles over here. Okay, I need to make sure you guys understand that, because we're on two separate transversals. It's like two completely different sets of angles and two sets of problems. So on this problem here, once we get to the 80-degree angle, now I'll put the ruler over this. This other line, BC, doesn't matter, doesn't have any impact on the problem. Okay, so now I'm looking, I say I don't have the Z, I've got 80 and I've got 1. They're both on the right-hand side of the transversal, so they're same side, and they're both inside my sandwich, right? So these are same side interior angles. Okay, so that means they got to add 180. 80 is little, 1 is obtuse. So I can say that the measure of angle 1 is equal to, or excuse me, the measure of angle 1 plus 80 has got to add up to 180. Subtract 80 from both sides, and the measure of angle 1 is going to be 100 degrees. 100 degrees, okay? Don't get wrapped up and think, oh, well, this is, angle 2, this has got to be 80 or whatever, because they're on two different transversals. Now, if these two transversals were parallel, then that changes everything, but they're not. Okay, so we got to go based on what the information problem gives us. 21 through 23. Okay, find the value of x and find the measure of the labeled angle. So once again, you guys are probably looking at this saying, oh, this is a quadrilateral and that kind of stuff. Let's just extend. Let's extend. Let's extend. And let's extend. Okay, we have the arrows, so we know those lines are parallel. So it's almost like I don't even need this over here. It doesn't affect the problem. I have my two lines combined transversal. X, that's a big angle. X minus 50, that's a little angle. If one's big and one's little, they are supplementary. They add up to 180 degrees. They are same side interior angles, so I'm going to say the x plus the x minus 50. That has to add up to 180. 2x minus 50 equals 180. Add 50 to both sides. 2x equals 230. Divide by 2. X is 115 degrees. Okay, it says find the measure of the labeled angles, so it wants us to find the measure of both of these. So if that obtuse angle is 115, then this acute angle has to be 180 minus that, or 65 degrees. Or we can just do x, 115 minus 50, and of course that also gives us 65 degrees. Okay, number 22, the triangle. Okay, so once again, I'm not used to seeing this. That's kind of a weird setup here, so let's extend. Let's extend. Let's extend. Okay, okay, here we go. Now I see there are my two parallel lines cut by a transversal. Okay, now the 3x minus 10, they're showing that in this little acute angle here. The x plus 40, that's also in this acute angle. Okay, so if they're both acute with parallel lines, they're congruent. They're both in the same position of the window, so if I were to draw my box, they're both in the bottom left-hand corner of the window, so they're corresponding angles, so they're congruent. So I'm going to set 3x minus 10, set that equal to x plus 40. 2x minus 10 equals 40, add 10 to both sides, and we get x is 25. Okay, so again, it wants us to find the measure of the angle, so if I plug in 25 here, 3 times 25 is 75 minus 10, this guy is 65 degrees, and if I plug it in right here, 25 plus 40 is also 65 degrees. Check, check. So that checks out. Okay, 23, again, we've got some kind of quadrilateral here, and these lines are parallel. Okay, so these lines are parallel. So basically, this line has nothing to do with these two guys. Once again, I could extend, 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 and then there are my two lines cut by a transversal. Okay, that's a big obtuse angle. This is a small acute angle, one big plus one little. They're supplementary. These are same side interior angles. Turn your paper, they're both on the left-hand side of the railroad tracks. So they're going to be supplementary. So 5x plus 4x, it has to add up to 180. 9x equals 180. Divide by 9, and we get x is 20. Okay, if I plug it back in there, 4 times 20 is 80 degrees. 5 times 20 is 100 degrees. 100 plus 80 does add up to 180. So check, check, check. All right, let's keep going. Okay, 24. Okay, so in these problems, they're asking us to find the value of the variables. Slow this back a little bit. Okay, find the value of the variables. Okay, these two lines are parallel, parallel, parallel. So that means if that's a 90-degree angle, then this guy has to be a 90-degree angle. They're corresponding angles in the same position. Okay, if this line is perpendicular, or we can use the other theorem that we learned, that if one line is perpendicular to one line which is parallel to another, then it's perpendicular to both of them. So that means all these guys, these are all 90-degree angles. So I can set this expression 6p minus 6 if that equal to 90 degrees. 3p, add 6 to both sides, 96 divided by 3, p equals 32. And that's what they asked for. Okay, 25 and 26. These are tricky. These are tricky, guys. Okay, so how are we going to find x and y here? I've got an x there, obtuse angle. I've got a y here, an acute angle. I've got a 3y here, an obtuse angle. And I have 0 numbers. 0 numbers. Well, what do I know about x and y? Okay, this is x, this is y. Okay, so don't they form a line? They're a linear pair. So I know I can say that x plus y is equal to 180 degrees. Okay, let's look at z. X plus y is equal to 180 degrees. Now, can I solve that? I can't solve that. I have 2 unknowns in one equation. I have more unknowns than I have equations. So that lets me know, maybe I need another equation. All right, well, what can I do with this 3y? If these lines are parallel, 3y is a big obtuse angle. X is a big obtuse angle. These are corresponding angles, right? They're in the same position in the window. They're both in the bottom left. So I know that these two guys are congruent. So I can say that x is equal to 3y. Okay, so I can solve a system of equations. Okay, so the easiest way to do this would be substitution. Okay, you could do this a couple of different ways. You could say that y is equal to 180 minus x. I already have my x isolated over here, so I think on the answer key, I actually isolated y. I moved this over here and plugged it in here. On this video, I'll do it the other way, just so you can see it doesn't matter. X is equal to 3y, so everywhere I see an x, I'm going to substitute with the 3y. So I'm going to take this guy and plug it in right there. Okay, so instead of x plus y equals 180, I have 3y plus y equals 180. That's 4y equals 180 divided by 4, and we get y is equal to 45 degrees. Okay, how do I find x? Well, x is equal to 3 times y. So x is equal to 3 times 45. That comes out to be 135 degrees. Okay, so the math wasn't all that hard, but it's a little bit tricky to figure out, oh my goodness, I got to actually set up 2 different equations so that I can solve for both of my variables. Okay. All right, number 26. Some of you guys looked at this and your brain exploded. Okay, that's okay. I know this is kind of a busy diagram, a lot of stuff going on here, but both sets of lines are parallel. So we got double arrows here, double arrows down here, single arrows up here. Okay, now I see a lot of different triangles. Now, if I knew 2 angles of a triangle, the first thing I thought about when I looked at this, I said, okay, if I knew 2 angles of a triangle, I can find a third one. So if I had this angle, I could add that and that together, subtract from 180 to get that. But when I looked at all these triangles, I only have one number in each triangle. So that tells me, okay, probably not going to be able to figure this out using triangles. So what else can I use? Well, we have parallel lines, right? So the first thing I look at, I look at this guy right here, W, okay? What other angle kind of matches up with W? Well, if these lines are parallel, then once again, I'm always looking for the Z. The Z, okay, don't I have a big Z here? It's backwards. But W and this 20-degree angle, aren't they in the little crevice of the Z? They are. So W and 20 are actually alternate interior angles. So W is going to be equal to 20 degrees. Oops. Yeah, W is equal to 20 degrees. I have another Z. I have, if I kind of turn my paper this way, I have this Z here. This is another backwards Z going this way. Another backwards Z. And then I have this angle, 87, and I have this angle. Those are both in the little crevice of my Z. These are alternate. And again, if you guys need to extend this out. Extend these out so it helps you visually see what's going on. Okay, so 87 and Z, those would be alternate interior angles. So X is also equal to 87 degrees. And then I can do the same thing with V. Okay, so if I kind of turn my paper here, if you need to turn your paper, guys, turn your paper. Here's a regular Z. Here's a regular Z. Okay, and there's my 42-degree angle, and here's V. Okay, so V and 42 are congruent alternate interior angles. So V is also 42. But now the tricky part is, how about Y? What do I do with Y? Because Y and Y are alternate interior angles, so that doesn't help me. So now I'm starting to think, okay, well, I have a lot of information over here. I know that V is 42. We already solved that. So I know that this whole angle, maybe I should do this in a different color. This whole angle in green and this whole angle in green, those are same side interior angles, right? This is a big obtuse angle in green. This is a small acute angle in green. So I know that same side interior angles have to be supplementary. So these two angles have to add up to 180, but I'm missing part of this angle. So basically what I'm going to do is I'm going to say this angle and this angle, 20 and 42, that adds up to 62. Okay, so this angle and this angle have to add up to 180. So basically what it boils down to is that the sum of that guy, that guy, that guy, and that guy, the sum of all of these individual angles, they all have to add up to 180. So I can say that angle Y is equal to 180 minus the 87, minus the 42, and minus the 20. Okay, if I subtract that guy, that guy, and that guy, I will get Y, and that ends up being 31 degrees. Okay, that's a little tricky, All right, let's keep going. 27, which solution for the value of X at the right is incorrect? Okay, big angle, little angle. One big and one little are supplementary. Okay, so nope, that's not supplementary. This is correct. That guy plus that guy has to add up to 180. Okay, the reason for that is because they are same side interior angles. Same side interior angles. Okay, and they're supplementary. Okay, 28, 29, 30, and 31. Okay, these can be a little bit tricky too. So here's the little trick that I told you guys in class. Here's how you do this. When you're trying to figure out, when you got a whole bunch of lines, you're trying to figure out which lines are parallel, figure out the lines that have nothing to do with the problem and eliminate that line. And then visually that'll help you see what's going on here. So number 28, it says which lines are parallel. I have this angle, these two angles have the little arcs. That means they're congruent. So I could put in a number, 100 degrees and 100 degrees. So now the trick is which line has nothing to do with these two angles. In other words, which line does not touch this angle? And the answer to that is BC. So if I were to cover up BC, okay, I just take that away, which two lines are parallel? It would be these two lines, right? This line and this line are parallel. It'll be lines BE and CG. Okay, so that's how you do it. So I think on the answer key, I just kind of scribbled through the line that has no impact on the problem. Okay, and then it becomes clear that these two lines are parallel. Okay, if these two corresponding angles are congruent. So I would say that BE, line BE, is parallel to line CG. Okay, and the reason for that is because these are corresponding angles. Okay, number 29, we got this angle here and this angle here. Which line has nothing to do with both of those angles? This diagonal line doesn't have anything to do with it. ST doesn't have anything to do with it. ST doesn't touch either of those angles. Okay, so if I extend this out, okay, which two lines have to be parallel? Again, these are corresponding angles. So PS and QT have to be parallel. These two lines are parallel. Take away the line that you don't need. So PS is parallel to QT. All right, 30. 30 is tricky. Goodness gracious. Okay, so I've got a 45-degree angle here and a 45-degree angle here. Okay, well, guess what I'm going to do? I'm going to extend. Okay, which lines have nothing to do with these two angles, these two 45-degree angles? This line doesn't have anything to do with it. What else? This line doesn't have anything to do with it. I can take those out. So basically I have these are my two lines, okay, cut by my transversal. See if you can visually see that. So that means that these two guys right here, HR and CA, have to be parallel in order for these, again, these would be corresponding angles. So I would say that CA is parallel to HR. Okay. Number 31, I have this angle, which is congruent to this angle. Which lines have nothing to do with that? LS has nothing to do with those angles. JQ has nothing to do with those angles. And this whole bottom line, QRST, this whole line has nothing to do with these two angles. Okay, basically I have this transversal, I've got that transversal, and I got these two parallel lines. So once again, these would be congruent corresponding angles. So I can say that KR is parallel to MT. Okay. All right, go back and watch that little part again if that's a little bit confusing for you. Okay, let's move on to number 32. Determine the value of x which makes the lines parallel. So now we're working backwards. Instead of them telling us that the lines are parallel and we solve for x, now they want us to figure out what does x have to be to make the lines parallel. But we work the problem the exact same. X plus 25, that's a small acute angle. 55 degrees, that's a small acute angle. So in order to make L and M parallel, these angles have to be congruent. These are corresponding angles. We're seeing a lot of corresponding angles. They're both in the same position of the window. They're both in the top right. So I'm simply going to set those guys equal to each other. X plus 25 equals 55. Subtract 25 from both sides. And we get x is equal to 30. All right, number 33. Okay, here we go. We've got 95. That's actually an obtuse angle. It's barely over 95. 2x minus 5. Now this one, a little bit hard to see whether or not it's big or little, but we do know that these are on opposite sides of the railroad tracks, right? And they are inside the hamburger. Okay, they are interior, inside my hamburger, opposite sides, so they're alternate interior angles. What's the little trick for alternate interior? Look for the Z. There's the Z. So to make these lines parallel, these two guys have to be congruent to each other. Okay, so I'm going to set 2x minus 5 equal to 95 degrees. Add 5 to both sides and divide by 2. And I get x is equal to 50. Okay. All right, number 34. That's a big obtuse angle. That's a big obtuse angle. They are both outside the sandwich. They're on opposite sides of the railroad tracks. So these are alternate exterior angles. Okay. And we know for these lines to be parallel, these two guys have to be congruent. So I'm going to set these guys equal to each other. And solve x minus 33 equals 26. Add 33 to both sides. And we get x is equal to 59. 59. Okay. We could go back and check that, but for the sake of video, I am going to let you guys do that on your own. Okay, number 35. Okay, we've got this 105 obtuse angle here, 3x minus 18. We've got this acute angle here. This guy has nothing to do with the problem. It's just extra information. By the way, that's the way the real world works, guys. I mean, you're going to have a lot of information in the real world that you don't need to be able to figure out your job, to figure out your project, whatever you're doing, whatever you guys, whatever career you guys decide to pursue. So don't be scared of extra information that you don't need. Okay, so to make these lines parallel, 105, that's a big obtuse angle. 3x minus 18, that's a small acute angle. When I have one big and one little, they are going to be supplementary. They're going to add up to 180. So I'm going to say 105 plus this other expression. Add all that up to 180. And if you solve that, you should get x is 31. This is going to be kind of a long video, so I'm going to kind of speed through some of this stuff. Okay, 36 through 45, it says use the given information to determine which lines, if any, are parallel. Justify your conclusion with a theorem or postulate. So we don't know anything about these angles or these lines. We don't know that anything's congruent, or we don't know that the lines are parallel. But if you tell me the angle 2, if you say that guy is supplementary to that guy, okay, then I know that two of the lines have to be parallel. Okay, well think what line has nothing to do with 2 and 3. Okay, that is line M, right? If I take away line M, I can still have 2 and 3 be supplementary. This guy has no bearing on the problem. Okay, so if you tell me that 2 and 3 are supplementary, then I can say that lines A and B, right, these two guys are parallel. So I can say A is parallel to B. And what do we call these? These are same side interior angles. That's a postulate. Okay, that's one of the few that's a postulate. The rest of them are theorems. Number 37, if you tell me 6 and 7 are supplementary, okay, it's the same thing. If you tell me those two guys add up to 180, then I don't need this line over here. It's the same exact thing. I can say that A is parallel to B because of the same side interior angles postulate. Okay. Number 38, angle 7 is 65, so 65, and angle 9 is 115. Okay, now you guys may look at that and say, that's 65 and that's 115, so obviously something has to be parallel. But remember guys, these are on two separate transversals. If we don't know that any lines are parallel, then this transversal, these 8 angles, have absolutely nothing to do with these 8 angles over here. Okay, for all we know, these lines could have been drawn like that. Okay, and it's still possible to have, you know, this obtuse angle be congruent to that obtuse angle, even though the lines are drawn all over the place. Okay, so this is not enough information. NEI, not enough information, because they're on two different transversals. It's kind of like saying I'm on two different roads. I have an accident right here at this red light and an accident right here at this red light. That has nothing to do with each other because they're on two completely separate roads. Okay. All right, 39, angle 1 and angle 8 are congruent. Okay, 1 and 8. All right, which line has nothing to do with those? This one has nothing to do with that. So if you tell me that 1 and 8, which are alternate exterior angles, if you tell me those are congruent, then once again I can say these two lines, AB, are parallel. And I'll say alternate exterior angles theorem, AEAT. All right, angles 11 and 7. So 11 and 7. Okay, if you tell me they're congruent, same thing, guys. They're on two separate transversals that have nothing to do with each other. So that's NEI, not enough information. Angle 1 and angle 3. I'll put a box around these. Angle 1 and angle 3. Okay, those are both in the top left of my window. Okay, so those are corresponding. If you tell me corresponding angles are congruent, which line has nothing to do with that? Line M has nothing to do with that. So I can tell you that A and B are parallel. And that's because of CAT, corresponding angles theorem. I'll abbreviate that as CAT. 42, 9 and 12. Okay, if you tell me that 9 and 12 are identical, then I still don't know anything about parallel lines because that's just vertical angles. I mean, vertical angles are always congruent, so that doesn't help me determine whether or not any lines are parallel. So that's another not enough information. 2 and 10, okay, 2 and 10. So which line has nothing to do with 2 and 10? Now this time, line B has nothing to do, we're going horizontal. B has nothing to do with angles 2 and 10. So if you tell me the 2 and 10 are congruent, those are corresponding angles, that means these two lines have to be parallel. So I would say lines L and M, L is parallel to M because of CAT, corresponding angles theorem. Angle 8 and angle 6. Okay, 8, I'll do a triangle, 8 and 6. Okay, once again, line M has nothing to do with angles 8 and 6. Those are corresponding angles. Okay, so I can go back to lines A and B. A is parallel to B because of CAT. All right, 5 and 10. 5 and 10. Line B has nothing to do with 5 and 10. These are alternate interior angles, so I can say that line L and line M are parallel because of alternate interior angles theorem, AIAT. Okay, let's move on back to some more algebra. Find the value of x that makes line L and M parallel. Okay, so if line M and L are parallel, then basically this line has nothing to do with these two lines. So I don't even need that 27x. So I like to just get rid of stuff I don't need. So now I'm looking at the 19x and the 17x. If these lines are parallel, 19x, I know it's hard to see, that's an obtuse angle. 17x, that's an acute angle. One's big and one's little. So they're supplementary, so they got to add up to 180. 19x plus 17x equals 180. 36x equals 180. Divide by 36, and x is equal to 5. Okay. Alrighty, let's move along. 47. Okay, what has to happen for x for L and M to be parallel? Okay, so here I don't need this line. I don't need this 5x. That has nothing to do with it. I'm just simply looking at these two lines cut by this transversal. 2x, that's a small acute angle. 5x plus 40, that's a big angle. One and big and one little add up to 180. So 2x plus 5x plus 40 is equal to 180. 7x plus 40 equals 180. Subtract 40. 140 divided by 7, and I get x is equal to 20. Okay. Again, if you guys think I'm going too fast, then slow down, pause the video, rewind it, whatever you need to do. Okay, let's keep going here. Now we're back to the parallel perpendicular line stuff, slope intercept, point slope formulas. So we did this in class a couple days ago. Write the equation of the line parallel to the line that contains points C. So here's our point slope formula that you will have to know. Y minus y1 equals m times x minus x1. Okay, the y and the x are just your generic variables. The x1 and the y1 is the point that we're going through, and then we have to find the slope of this line and determine whether or not we want it to be the same or the negative reciprocal, depending on whether or not it's parallel or perpendicular. And so these first couple of ones, they want us to find a line that's parallel to that line. So that I know that whatever my equation is going to have a slope of negative 2x, okay, because the slopes of parallel lines are the same. So now I know what my slope is, okay, it's negative 2x, and then I'm just going to plug in my x1 and my y1 for this point here. This is my x1, this is my y1. So I simply plug it into my formula. So I have y minus y1, y minus 3, is equal to my slope, which we said was negative 2, parentheses x minus x1, which is 0. So that's y minus 3 equals negative 2x. Add 3 to both sides, and I get negative 2x plus 3. That is the equation of a line that's parallel to this line, because they both have a slope of negative 2, but will pass through that point. Okay, 49 is the same exact thing. x1, y1. I know my slope has to be the same, so my slope is going to be equal to 1/2. Okay, so I'll plug into my formula here. Y minus y1 equals my slope times x minus x1. Now here's a double negative here, so tricky. Don't forget that, just like the distance formula when you're subtracting a negative. So this is y minus 4 equals 1/2 times, change that to a positive, that's x plus 2. Y minus 4, if I distribute, that's 1/2 x. 1/2 of 2 is 1. And then I add 4 to both sides, and I get y is equal to 1/2 x plus 5. Okay. 50 and 51 are the same thing, except for now we're looking for a line that's perpendicular to the line in question that goes to that point. So now remember, for a perpendicular lines have negative reciprocal slopes. One is going positive and one is going negative. Okay, so what is the negative reciprocal of 1/2? You change the sign and you flip the fraction. So my slope is going to be negative 2. Flip that upside down and add a negative. I still have my x1 and my y1, so I'll plug it into my formula back up here. So I have y minus y1, or y minus 0, equals my new negative reciprocal slope times x minus x1. Okay, so I get y is equal to distribute, that's negative 2x plus 8. Okay, let's keep going here. Number 51. Okay, I want something that's perpendicular to that guy. So what is the negative reciprocal of negative 2? Change the sign, so it's going to be positive, flip the fraction. This is 2 over 1. Any number can be written as something over 1. So if I flip that, that's going to be a positive 1/2. x1, y1. Okay, so I have y minus y1 equals m times x minus x1. Y minus 4 distribute equals 1/2 x. 1/2 of negative 4 is negative 2. I'm going to add 4 to both sides. Y equals 1/2 x plus 2. Okay, so 52 and 53, they want us to rewrite the equations in slope-intercept form. Remember, slope-intercept is y equals mx plus b. M is my slope, b is my y-intercept. This is just a function where this line, y depends on x, output depends on input. Determine if the lines are parallel. Okay, so I got to rearrange everything in this form and see if the slopes are the same. So here I'm good to go. I'm in that form. Here I'm not. I need to move the x to the other side. Y equals negative x plus 20. Now I'm in y equals mx plus b. I have a slope of negative 1. I have a slope of negative 1. So yes, those guys are parallel. 53, I got to do some rearranging here. I need to get y by itself, so let's move the 3x to the other side. 4y equals negative 3x plus 12. I need to divide everything by 4. Y equals negative 3/4 x plus 3. Okay, this guy, I need to isolate the y, so let's move the 6x to the other side. So 2y equals negative 6x plus 6. Divide everything by 2. Y equals negative 3x plus 3. So here are my two equations. Are they parallel? No, they're not parallel because one has a slope of negative 3/4, the other has a slope of negative 3. So those don't match. 54 and 55, they're asking us if the lines are perpendicular. Now 54, are we in y equals mx plus b form? Y equals mx plus b. I don't see an x. So that must mean that my slope is 0. So this is like y equals 0x and my intercept is 3. 0 times anything is 0 and I just get y equals 3. So my slope is 0. That means my ski slope is flat. I have no slope. Okay, so if I were to plot this on the coordinate grid, this would be a flat line with a y-intercept of 3, right? So 1, 2, 3. So this would be the equation of the line y equals 3, a perfectly horizontal line. X equals 2, I don't even have a y. Okay, so that means that my slope is infinite. Okay, so that means I have a vertical line. I have a vertical line, here's the origin at 0, 0. I have a vertical line that crosses the x-axis at negative 2. 1, 2, negative 2. So here's my vertical line. So that is x equals negative 2. So I have a horizontal line at y equals 3, a vertical line at x equals 2. So yes, of course, those are going to form a 90-degree angle. And those two guys are indeed perpendicular. Let's see if I can get my camera to refocus here. Can you do it? Can you refocus? There we go. That's better. Okay, now the other way to remember this, the way I teach this, is when you see an equation where it has just an x or just a y, whatever axis it crosses, okay, that's going to be the equation of the line. So y equals 3, it has a y in it, so that means I'm crossing the y-axis. So that tells me that's going to be a horizontal line. X is going to cross the x-axis, so that tells me it's going to be a vertical line. That's a little simple way to remember that. Okay, 55, we need to get this guy by himself, so let's subtract 2x from both sides. Negative 7y equals negative 2x minus 42. Divide everything by negative 7. That's going to be a positive 2/7 x plus 6 for that equation. Here I just need to divide everything by 4. Y equals negative 7/4 x minus a half. Okay, so obviously 2/7 and negative 7/4 are not negative reciprocals of each other. So no, these two guys are not perpendicular. Okay, home stretch, guys. We're almost there. We're getting there. All right, last page. Here we go, last page. See if I can keep this video right under an hour at 55 minutes. I'm not sure I can do that or not. We'll see. All right, 56. Find x, jk, and jm. Okay, so what do we know? This is an angle bisector, right? Angle bisector. So that means this is the spider web theorem, right? Any spot on the angle bisector is going to be equidistant from the sides of the angle that form 90-degree right angles. Okay, so all these distances are the same. So that means these two guys are the same. All right, so I'm going to set those equal to each other. So x plus 5 equals 2x minus 7. If you move the x to the side, 5 equals x minus 7. Add 7, x is equal to 12. All right, so if I plug that back in, 12 plus 5 is 17. 2 times 12 is 24 minus 7. That's also 17. So that checks out. Okay, 57. Find y, st, and tu. We have another angle bisector here because we have the arcs. So that means these distances are the same. This, again, this is the spider web theorem. Okay, so I'll set those equal to each other. 5y equals 3y plus 6. Subtract 3y from both sides. 2y equals 6, y equals 3. So let's plug that back in here. If I plug it in here, 5 times 3, that st has a length of 15. Plug it in here. 3 times 3 is 9 plus 6. Tu also has a length of 15, and that checks out. Okay, 58 through 62, we're using this diagram over here. This is our perpendicular bisector theorem. This is the one that says if I've got a perpendicular bisector, then any spot on that perpendicular bisector is going to be equidistant from the endpoints of the line segment that I'm bisecting. So first of all, it says find the value of x. So I know that these two lengths are going to be the same because I'm on the perpendicular bisector. So that distance and that distance will be the same. If I drew another dot, that distance and that distance will be the same. So I'll set those equal to each other. 2x is equal to 3x minus 5. Subtract 2x from both sides. I get 0 equals x minus 5. So x equals 5. Okay, find TW. I'm simply going to plug this in here. 2 times 5 is 10. For WZ, 3 times 5 is 15 minus 5. That is also 10. So that checks out. What kind of triangle is TWZ? What kind of triangle is this? Those two sides are the same, and this side is not. So when I have two sides of a triangle that are congruent, that is Mr. Isosceles triangle. Number 62, if R is on the perpendicular bisector of TZ, then R is blank from T and Z, or blank is equal to blank. Okay, so I got R. It says R is on the perpendicular bisector, so we're on this line. Okay, now what can you tell me? R is blank from T and Z. R is blank from that guy and that guy. Whoops, that was horrible. That guy. What can you tell me about those distances? They're the same, right? So I can say that R is equidistant. Is that $5 word? Equidistant from T and Z. Or I could say that these two segments, TR and RZ, TR is equal to RZ. They're congruent. Okay, 63. Determine whether A must be on the bisector of angle TXR. Okay, is A on the bisector? No, it's not, because these two distances are not the same. Okay, TA and AR would have to be the same distance in order for A to be on the angle bisector. 64. Okay, what can we say about 64? Is A on the, so answer to this one is no. Is A on the perpendicular bisector? Yes, it is, because we have the arcs right here, right? So if they give us the arc, that is the angle bisector. So answer to that is yes. 65, is A on the perpendicular bisector? We don't know anything, we don't know that the angles are being split, but they're telling us that that distance and that distance are the same, forming right angles right here. So yes, that means that A has to be lying on the angle bisector. Okay, again, this is the spider web theorem. All those distances have to be the same. So the answer to this one is yes. Okay, in this diagram, let's name a median. Okay, what is a median? A median goes from the midpoint. Now, all this stuff, 66 through 73, only apply to triangles, okay? Points of concurrency inside a triangle. So a median is a line that goes from the mid-segment of the side of the triangle to the opposite vertex. So here's a BC that is being split by E because I have these ticks here. Okay, so those two segments are congruent. So I can say that this guy, which is the midpoint of BC, draw it to the opposite vertex. That would be a median. So that's going to be AE. AE is a median in triangle ABC. Altitude, remember the airplane? Airplane guy jumps out of the parachute and drops straight down. Okay, for the altitude. Altitude means high or height. Okay, so an altitude from A, B, C. So here we are in our little airplane, right? And the guy jumps out of the airplane, drops straight down, forming a 90-degree angle. So BD, so altitude goes from a vertex, a corner of the triangle, and then drops straight down to the ground to the other side. So BD would be an altitude. All right, what's a median in triangle DBC? So now we're only looking at DBC. We're only looking at this triangle. Okay, again, the only midpoint that I have is still sitting here at E. But now if I'm looking at this triangle, I got to draw the median from the mid segment to the opposite corner. So I'm going to this corner of this vertex of this triangle. So that would be ED or DE. An altitude for AOC. AOC. Color code these things, guys. Okay, here's the airplane. I'm dropping that airplane straight down to the ground. OD. That's my altitude. All right, here's where we got to use our little saying, right? All of my children are bringing in peanut butter cookies. Okay, all of. Altitudes intersect at the orthocenter. My children. Medians intersect at the centroid. Are bringing in. Angle bisectors intersect at the incenter. Peanut butter cookies. Perpendicular bisectors intersect at the circumcenter. How can you tell the difference between these two C's, the centroid and the circumcenter? Centroid is shorter than circumcenter. My children is shorter than peanut butter cookies. Okay, so where do all three medians intersect? Medians intersect at the centroid. That is the center of gravity in any triangle. Where do the three perpendicular bisectors intersect? Perpendicular bisectors intersect at the circumcenter. That's the longer one. Where do the three angle bisectors? Angle bisectors intersect at the incenter. Where do the three altitudes intersect? Altitudes intersect at the orthocenter. I didn't get it. Hour and 4 minutes. I was close. Close to keeping it under an hour. All right, that's a lot of stuff, guys. All right, but remember, if you can do all these problems on this review, there may be a quadratic on the test, maybe, I don't know. Okay, so hopefully you guys enjoyed this, and we will see you on the next video. Good luck.